Welcome to Pen and Paper Programming. We are going through Elements of Programming Interviews book, questions, and we are in Chapter 4, Primitive Types, and working on the variant questions. So variant questions have the following constraint. Write expressions that use bitwise operators, equality checks, and Boolean operators to do the following in constant time. The third variant question is asking us to test if x is a power of 2. Evaluates to true for x when x is 1, 2, 4, 8, basically power of 2, and false for all other values. So if you haven't gone through the question, second variant question, you can take a look at it in the previous video. It's a similar question, but it's always good to write down some examples to see if there's a pattern that you recognize. And once you recognize that pattern, you try to generalize in a function. That's what we're going to try to do. So power of 2's in binary is very clearly either in the case of 1, only this first bit is set, everything is 0. In the case of 2, the second bit is set and everything else is 0. In the case of 4, you have the third bit set, 1, 2, 4, everything else is 0, and so on and so forth. In the case of 8, only this bit set. In the case of 16, only this bit set. You know how binaries work, right? If it is not a power of 2, then you have other bits set. For example, in the case of 7, you have multiple bits set. So not only the first one, second one, or third one, as you see. In the case of 8, as I said before, 1, 2, 4, 8, this particular fourth bit is set. So in the case of power of 2, we realize there's only one bit set in the number. So what that means is, if we find a way to, for example, erase that bit, the only set bit, the number should become 0. What I mean is, if I can find a way that I can just unset this bit, like the second bit here, if I can find a way to do that, if I can turn it into 0, that means my number overall should equal to 0. And we learned a way to do that actually. If we, in the case of, let's actually write it right here. In the case of 4, 5, 6, 7, 8. In the case of number 2, if I want to erase this bit, I learned that I can take this number, let's say it's x, I can subtract 1 from it, x minus 1, let's represent that, that would be 1, 2, 3, 4, 5, 6, 7, it's x minus 1, right? And if I AND these two numbers, what will I get? I will get this number erased, which will become 0. So we learned it previously, but if you want to erase that a particular bit, you can actually subtract 1 from it and end it, and that's going to basically get rid of the least significant set bit right here. So our definition, function definition is x power of 2 takes an x. It ANDs x with x minus 1. When we do that, we should get a 0. As I said, in the case of power of 2, you only have one bit set in your number. And when you AND it with x minus 1, you are erasing that only set bit. And once you do that, it should become 0. If it becomes a 0, then that means you have an x that is power of 2. There's another exception. There's an exception to this, which is when x is 1, which is 2 to the 0. 2 to the 0 is 1, right? The first. If x is 1, that's also a power of 2. So basically, it's a power of 2 if x ended with x minus 1 is 0 or x equals 1. I hope this makes sense. Again, previous question, a variant question, is also very similar, but the whole concept is basically to write down number, a couple of examples to see a pattern. Our major pattern here is, in the case of power of 2, I will only have one set bit in my number. If I can unset that bit and my number turns into 0, that means it's a power of 2. That's what we're trying to do here. And this is a good bit trick that you should memorize. That's the way to do it. And if it is 0, it's power of 2, or when x is equal to 1, which is a power of 2. I hope this makes sense. If it doesn't, leave a comment. I will answer your questions.